Okay, so I guess we can start this session if I am right. We are on the stage. And so, good afternoon. It's a big pleasure to introduce this side event for the Geo Week and on the GOS4M, which is the Geo flagship on Mercury, supporting the different action, different tasks of the Minamata Convention on Mercury. So this is a kind of follow-up side event to the plenary speech that I personally give at the opening of this Geo Week on Tuesday. So I hope that all the attendees had the opportunity to listen the overview of this Geo flagship. However, this afternoon we will talk primarily about monitoring effort that several institution partners are carrying out in order to monitor Mercury in different environments worldwide. And so you will have a quite quick overview of current monitoring activity in different regional and global scale monitoring network. And also how we go from data to knowledge. So as soon as you have this huge data set, what we do with data. And the goal of the flagship is really to develop the so-called knowledge hub that you can play with if you go on the GOS4M web portal. So you can have all the facility to play with this knowledge hub and see how you can design emission reduction scenario and what could be the likely effect in terms of deposition fluxes to terrestrial marine ecosystem. So this afternoon, in this short side event, we will talk about monitoring effort. And for that, I'd like to introduce one of the co-chair of the flagship, that is Dr. Alexander Steffen from Environment Canada, which who will talk about, give you an overview of the flagship with a special focus on monitoring and knowledge hub, and also will be followed by intervention of other distinguished colleagues from different parts of the world. So I will stop here and I like to introduce Sandy Steffen. Please, Sandy.
Thank you, Nicola, and welcome to our session. We're just going to start off by giving you a brief background on Mercury in the environment, because this is a bit of a different beast than what the rest of the Geo Week really talks about. So why are we concerned about Mercury? And Mercury has a long lifetime in the air that actually makes it thus a global pollutant and very applicable to the Geo platform. Mercury is bioaccumulative and can be in certain forms of neurotoxin. Mercury is naturally, anthropogenically, and re-emitted. So it's complicated. It's just not a single anthropogenically emitted species. Generally, the primary sources are coal burning, mining, smelting, mercury in products, and artisanal scale gold mining. And those are the main sources of mercury to the atmosphere. We want to talk today about how our monitoring and network then apply to policy-related initiatives. And this is specifically for the Minamata Convention on Mercury that has the overall goal of mercury reduction in the environment and human health around the world. So in order to be able to fulfill obligations within Minamata, we need global monitoring, succinct monitoring, and applied modeling. And so that's what the attempt of the GOS4M is with regards to that. So I'm just going to say this briefly because Nicola introduced it very well. It's a flagship program that introduces several operational networks into one big infrastructure. Today, what we're going to focus on in terms of that infrastructure is the atmospheric mercury monitoring that's going on and how that applies within the GOS4M system. So again, it's a coordinated global network and enables the gathering and availability of data into one central platform that can then disseminate comparable data to anyone who wants it, and then have an online modeling function to provide scenarios, to provide answers to science and policy type questions. So the main way that the GOS4M is organized is basically from observations to knowledge in a 5-step function. So we have the data compilation, which is the knowledge collection function. We have metadata and documentation of the data that comes in, and that's basically what we call the knowledge formalization. And then we have the knowledge sharing, which is basically the data and output downloads, and that's something that the end user can use. The use of the knowledge then is done through model simulations. And then finally, we say the knowledge generation, which are products for policymakers in terms of policy related to scientific questions. And that's where the data, the decision maker will be using this function. So the networks we're going to be talking about today that all lead into here, you can see there's a plethora of different networks that we are contributing to this. There are others that we're not, we have not included today, mostly because they're not officially onboarded onto the program yet. So
Sandy,
I want
Sandy, sorry if I interrupt you, but we don't see the slides.
Oh, really?
Yeah.
I don't know how to. Okay. Did you see them before?
No, we never saw. That's why we were waiting to.
Okay. I don't know what's going on there.
You should share the video. You should share your screen.
I'll reshare my screen again.
Yes, please.
Maybe when it switches from person, it switches there.
Okay, now you are on. You are on. Put in presentation mode.
Yeah, I'm clicking. There we go. Okay.
All right, that's much
All right.
better.
Well, the good thing was you didn't miss too much. It was mostly just talk and nothing very exciting. So here's now our first slide that you can see to talk about the different air monitoring networks that feed into the GOS4M. You can see we've got quite a few that we want to discuss today. So the first network that we want to talk about is that from China, and our colleague from China couldn't make it today. So I'm going to actually stop sharing my screen, and we will have a little video of the work that she's done. So Sarah, if you could play the video.
Hi, this is Shuxiao Wang from Tsinghua University. I'm honored to have this opportunity to share the status of atmospheric mercury monitoring in China and its policy implications. First, it is a pity that there's no official monitoring network for atmospheric mercury pollution in China. Fortunately, there have been about 20 atmospheric mercury stations supported by different research activities. The left table shows the detailed location, monitoring period, and the mercury species monitored by these sites. Among these sites, 9 sites supported by a 973 project monitored both GM, PBM, and GOM and wet depositions. These monitoring activities help us to characterize the levels and forms of atmospheric mercury at a given location and time. For example, the left figure here shows the mean concentrations at 9 stations supported by the 973 project in 2014. It can be seen that both the observed GM and the PBM concentrations are higher than the background mean values in the North Hemisphere. These observations are also very useful for the model evaluations. The red figures here shows the comparison of GOS'M model simulations with observations in 2 sites, which are Mountain Changbai Station and Chongming Island Station. Some of the monitoring sites have been run continuously for many years and can provide long-term trends of atmospheric mercury pollution. Generally speaking, that although the observed temporal variations differ spatially in China, the atmospheric mercury levels have been decreasing since year 2013. For example, the monthly mean GM concentrations at Chongming Island showed a significant decrease at a rate of 0.6 nanogram per cubic meter per year during 2014 to 2017. Similarly, the air mercury levels in Beijing followed a decreasing trend of 0.37 nanogram per cubic meter per year during year 2015 to 2019. Are these observed mercury decreases attributed to the anthropogenic emission controls? There's no doubt that atmospheric mercury concentrations is an important indicator for evaluating the effectiveness of mercury emission control. However, the changes of atmospheric mercury concentrations are affected not only by anthropogenic emissions, but also by regional transport, global background values, and meteorological conditions. Attributing the observed changes in mercury levels to actions influenced by anthropogenic emission controls requires the use of different models. Taking Beijing as an example, we applied a statistical approach, that is the generalized additive model GAM, to explain the decline of atmospheric mercury concentrations. Compared to chemical transport models, GAM assessment requires easily obtained meteorological parameters and use a relatively simple computation process, so making it suitable for rapid assessments. This statistical model represents better the variations of air mercury concentrations, and the adjusted R-square reached 0.55, which is better than the chemical transport models. And the contribution of each independent variable was determined by calculating their relative importance. Carbon monoxide contributed to 51.5% of total TGM variation, indicating that anthropogenic emissions was the dominant factor. And differences in meteorological conditions contributed to 47% of TGM variations, while the global background only made up 1.4% of TGM variations. And to further quantify the effectiveness of mercury emission control measures, we usually need to use the emission inventory and coupled with atmospheric chemistry transport models such as CMAC, GOS'M, and so on. Here we quantified the emission reductions of air mercury in China and applied GOS'M model to quantify the effectiveness of different air pollution control measures on air mercury levels. We can see that the mercury reduction from power plants and industrial boilers contribute for about 77% of the total air mercury decreases during year 2013 to 2017. So here are the take-home messages. First, there's no official routine atmospheric mercury monitoring network in China, so establishment of a network shall be prioritized. Secondly, limited existing air monitoring data suggests that China's atmospheric mercury levels have been decreasing since year 2013. Both statistical models and the CTMs confirms that the atmospheric mercury decrease in China is mainly caused by the mercury emission control measures. So if we have a coordinated global network, such as Deals for Mercury, that definitely will help us better answer the policy questions related to the Minamata Convention on Mercury. This is my talk. Thank you very much for your attention. If you have any questions or suggestions, you are welcome to contact me.
Okay, can I go back? And I will now continue sharing my screen. Okay, so Dr. Wong really just showed us that the real value of having global treaties, we can demonstrate very good reduction in our ambient atmosphere from emission control measures. So I just want to go through now a few more networks that have been will be providing information to the GOS4M platform. So one major network that's been running for well over 20 years, 1996, 20 years, is the U.S. Atmospheric Mercury Deposition Program, and it runs several different networks. One is an atmospheric speciation mercury network. One is a wet deposition network that looks at total mercury in precipitation and then calculates the deposition. And they're also looking at dry deposition of mercury through what we call litter fall. So basically taking the leaves from different areas and understanding what mercury has been accumulated through there. And so they collected on a weekly samples, and here's a good overview of the different sites they have around the US. And then this is some of the products that they come up with. So you can see they've been running for a long time. So 2003 to 2018, such really good products on terms of concentration. You can see the changes over time. And that's run by the US. In Canada, we've been running monitoring in the atmosphere since 1995. And just to show you here, these are our current stations in Canada. The bigger dots.
Sorry, Sandy, you are not in presentation mode. The slides don't go on.
Okay, let's try it again. I'll stop presenting.
No, you have to do sharing the screen.
Yeah, I have been doing that. Yeah. Okay.
Good. Presentation mode?
Let's try it again. Is it there?
Yeah, I can see. But...
Is it in presentation mode?
No.
And this worked earlier, so I'm not sure how to do.
Okay, just never mind. Just to go on with the slides.
I really don't know how to change this here. Let me try a different screen. Stop sharing. I apologize for this. We did test it out earlier and it was working fine. Let's try a different screen here. There, that should work.
Okay, that's good.
Can you see? Well, okay, my apologies for that. Okay, so in terms of Environment Canada, you see in the bigger red, the bigger dots here, we have our various wet deposition sites and our air concentration sites. And then this smaller dots, we've actually started a new passive air monitoring program. So some of the products that we've come up with in Canada as we do statistical measurements and monitoring to look at our trends with time. And you can see Canada is a big country, so we have a variation in trends over the different locations. And also using our chemical transport models, the GEM-MAC mercury model, which is the Canadian global mercury model, to look at deposition, emission impacts on deposition in Canada. We have recently started a collective project, a pilot project, using new Canadian technology to look at sampling mercury in the air on a passive way. So it's a new type of mechanism. And we are trying to work on this as a network of networks suggestion and idea. So we build on whatever existing infrastructure there is. And whether it's a Mercury monitoring network, a POPs monitoring network, or other type of networks, we start deploying these passive samplers around the world and are analyzing the mercury on a common scale. And this started in 2019, so it's a very new project. We have 43 sites in 23 countries. We're combining 4 different networks, and we're going to start to include also the European driven network, the GMOS.
GMOS.
Thank you, GMOS. And so this is a really good way now that we can sort of fill the gaps of data and start integrating everything. And then this data will be housed in the Canadian network and linked to the GOS4M so that we can increase our spatial variability and address the gaps. And so here's some preliminary results. They really show the global average is around 1.3. We have certain regional areas. So the Canadian network is showing variability. We do it every quarter samples. And then we did in the US recently a test pilot project. And now the NADP that I spoke of earlier has engaged with this and have started to take this passive sampler in their network as well. So now I will let Linwell speak about the South African network. Linwell, just tell me when to advance the slide. You're on mute.
Okay, thanks, Sandy. Good afternoon and good evening, everybody. So I'm quickly just going to present on mercury monitoring in South Africa, and specifically the South African Mercury Network. That is a network that started last year in 2020. Just to give some background in terms of mercury monitoring in the country, mercury monitoring started in South Africa in 1995 at the Cape Point Global Atmosphere Watch Station. So we have been measuring mercury in the atmosphere for around 25 years. And the Cape Point station is the longest running station in the Southern Hemisphere in terms of continuous mercury monitoring. In 2007, the monitoring program expanded and we added wet deposition monitoring as well through a collaboration with Rob Mason in the USA. And then in 2008, the Mercury Reference Laboratory was established at the Council of Scientific Industrial Research here in South Africa. And so Cape Point was the only station for around 20 odd years monitoring mercury in South Africa. And it is basically classified as a background station. So it doesn't really represent what is actually going on within the country. So the whole idea behind the South African Mercury Network was basically to expand the ground-based mercury monitoring stations within the country, and also that SAMNet can be the link into Africa through the AfriGeo platform. Next slide, please, Andy. So this is what the situation is currently in the country. So we have the Cape Point Global Atmosphere Watch Station, which is the background station that's basically located down at the site. Currently, we have 2 stations where mercury is being monitored continuously. The one is at Cape Point and the other one is at Valgagun, that is more up in the north in the country. And then we will be having 2 sites starting in the beginning of January. That will be in the R, more in the middle of the country, and then in Mglaleni or Witbank, it's previously known, that is in the region where most of the coal-fired power plants is located within the country. Currently, we have 6 passive sampling sites, which is spread throughout the country. And then we have also 3 passive sampling sites that is collaborating with the national or the global mercury passive program, which Sandy just spoke about. And then we've got 3 wet deposition sites, one at Cape Point and one at Valgagun and one in Stellenbosch. And then in the beginning of next year, we also will be starting with speciation monitoring at Cape Point. Next slide, please. This is just some pictures of all the sites, or let me rather say of some of the sites where we are doing the passive sampling monitoring. It's located throughout the country, where we've got no sources background, and as well at some of the sites which is very close to the coal-fired power stations. Next slide. Then in terms of the SAMNet network, we also have a human capital development program which is running. From this program, we've got 2 students that started this year with a PhD, and these are the topics that they will focus on. And then we've got 5 students that also started this year with the MSCs that will focus on those topics which is there. And as you can see, there is a variety of aspects which they will focus on, but the most important ones currently for us is the PhD project that will focus on the Atmos Mercury monitoring and wet deposition at the inland regional site. So that will be at the Valgagun site. And then also in terms of modeling, because there's not a lot of data available for the Southern Hemisphere, as you might know. So, I mean, through this network and through the stations that we will establish, and also the idea is to move up into Africa, and then also then use the data that we gather, either be it from passive wet deposition or from continuous monitoring, and then use this data that is collected through the SAMNet network, and then try and see if we can't do some modeling too. We've done some preliminary runs and studies, so we are definitely moving forward in terms of the modeling, something which I'm very proud of, as well as there's not a lot of data available in Africa as a whole. So hopefully through the SAMNet network, we will be able to expand up into Africa, and also encourage more African countries to become involved in mercury monitoring and also contribute towards the GOS4M. Thank you, Sandy.
Thank you, Linwell. So I'm just going to move here to the next monitoring network we have, which is the Asia Pacific Mercury Monitoring Network, which is a network that's been established in 2014 and has been growing by leaps and bounds. And this network is about measuring the wet deposition of mercury. So these are all the sites that are part of it, and all the data gets sent to the National Central University in Taiwan. So this is a US-Taiwanese driven initiative. And then we have the GMOS program, which has been running since 2010. And it was a very large network, and that has really what led into the GOS4M GEOS flagship program. And the initial group had land-based measurements, oceanographic campaigns, passive sampling networks, and aircraft campaigns. But with regards to what we're discussing today, it's mostly the ground air monitoring stations that are going to be combined with this big entity of all our network of networks here. And just to show you quite a famous product from the GMOS group, that they had so much data they collected, they could really put together a beautiful hemispheric gradient of atmospheric mercury concentrations, demonstrating sort of the differences on a global scale. So overall, what sort of products get developed within each of these networks? As I showed you before, the NADP has their total concentration, they have total deposition, and they show these kinds of maps that you can get on their online sites. If you go to the GMOS site, you can go in and plug in to each of the sites that have the data, and they'll then set up and show here. This is just looking at the concentration data from a selected site, so that's online. We can see in Canada, we don't have online functions like this, but we do deliver sort of maps on deposition and concentrations that are based on the measurements that we've collected. So for the GOS4M group, quality of data is, of course, fundamental. And this is a development of a system to achieve comparable data that builds on existing infrastructure. So we're not reinventing the wheel. So within this system, we share quality control, standard operating procedures to normalize the data. So we want to take in all the SOPs that they have and do an intercomparison similar to what the US and Canada did on their mercury speciation data. We also want to make sure we have instrument and technical intercomparisons that show that we have suitable equivalent instrumentation or suitable equivalent methodology, so the passive and the active kind of thing. And then the data reported must meet these foundational thoughts for data. We have a very strong, flexible metadata system within GOS4M, and then we produce these tools we want to produce tools to harvest data from other databases. So currently, right now, it is set up that the data is on this platform, but we want to be able to harvest data from these other networks. So I just want to quickly go into how exactly we deal with the data. So the monitoring of data is collected and QC'd. Here's just from the platform where the metadata is collected and shown. The data itself is submitted, so you can see and download the data from the sites here. The data is archived, and so when you go into the GOS4M site, you can see all the different sites and then click on where each of those sites is. So now we want to understand, getting to this point that we have this plethora of Mercury monitoring data and where that can fit into this science policy. So what we want to do with the data is increase accessibility, increase our ability to fill data gaps, and strengthen the current systems, plan new tools to enhance monitoring based on those gap information, integrate and provide collaboration, provide a platform to develop and support products for science questions. But as we said today, we want to talk about the policy questions. So then what we say is, what does GOS4M actually do with this data? So this is our platform website. And so we go into the area here to look at either, we're going to talk today about the data catalog or the knowledge hub. And so if we go about the data catalog, as I said, this is where the data is archived and you get your selection of monitoring sites. And so say you pick one, I picked Pallas in Finland. And then you click on this and you can see here's a picture of it. Here's the map of where it is. This is the general information about it. And then if you want to download the data, you go to the download function, and I'm old-fashioned, so I always go for a CSV file. And then you can take that data home and plot that up. So it's very, very straightforward and easy to use and very accessible to be able to see these data. So there's two things. We have the monitoring information, and then we want to look at the attribution, because attribution is key in the science policy world. So we apply this, we apply a model to the monitoring data that we've collected. We're using known models, so chemical transport models generally. We intercompare those models. We employ mercury emissions that have been reported, assess the deposition, and then assess the impact of mercury reductions. So this is through the Knowledge Hub in the GOS4M platform. So I just want to, again, go through some examples just to show you how cool this really is. So here we have at the base, you can pick your different inventories, and you can actually pick which different models you want to go into. And so just to show you, once you do that, here you've picked your model. So we have, this is the emissions the emission situation here. And so right now the current global deposition is 1,912 tons per year of mercury. And so I have, just to have where nothing changes, you put in that you have 0 changes in the emissions from the various regions. And of course, you don't really end up with any change in your deposition either to land or deposition to ocean. And here are different regions. And you can see by doing nothing, you don't accomplish very much. So then when we put another scenario in, I put, since Asia tends to be the highest emission source of mercury to the atmosphere in the world, I put all of the changes in emissions from the 3 highest regions to 100%, and saw then we see a change in deposition here from 1900 to 900. And then you can see here, we've got the bar graphs that show you the changes. So this is where we're usual. And then the black bar here is the new scenario that I've come up with. And then you can see the regions and where that is impacted. So that's based on this beautiful chemical transport model. So for me in Canada, the Arctic is always my main concern because that's our most vulnerable area. And you can see by changing 100% of the Asian emissions, we get 50% reduction of mercury deposition in the Arctic. So let's just have one more scenario where we have somewhere like Australia that generally don't think that it has much of an impact on other areas. And then when you put that in the scenario, you can see it really only reduces global deposition by 100 tons, if that. Maybe it's like, actually, it's just 40 tons. And you can see that our reductions are more specific here in Australia, but they're really not impacting. And again, I go to my go-to is look at the Arctic. And so if we're changing the emission scenarios in Australia, we're not really changing what's going on in the Arctic, which is not shocking. So finally, how does this help us with our international treaties and conventions? As I mentioned, the Minamata Convention is our primary tool and mechanism by which we can have impact on reducing mercury on a global scale. There's two treaties within, there's two articles within the treaty that really deal with monitoring and measurement and action, and that's the effectiveness evaluation, which is the article in which we are obligated to assess within 6 years of it going into force how effective the treaty as we've set it up has been. And then part of the data that feeds into that is under Article 19, which is the research, development, and monitoring. Now, recently, we've been working as different parties and countries together on a monitoring guidance, and AIR has been one of the media that is chosen. And actually, Dr. Linwell Martin here was the lead of this AIR chapter on monitoring. And within there, there's a tiered approach to how we guide people on monitoring. And so the first tier is mostly the base level air monitoring concentration. So the passive air sampling, the active air sampling that's done within all of these networks, and the wet deposition, that is our tier 1 for air. The tier 2 for air is to start trying to understand the trend attributions. So a bit more of that modeling piece. And then the third one is the process understanding. So that's getting to the nitty gritty that goes into the model function. So within the way in which the way in which we're proposing a framework to move forward on the convention and the effectiveness evaluation, we as a group have suggested this 6th level where we go from identification of information all the way up to informing the conference of the parties to make their decision on whether or not the treaty is effective. And so within here, the monitoring data that we're collecting and the monitoring activities fit at the base of that. So it's fundamental to understanding the effectiveness. And then something like the GOS4M, again, we've got the monitoring data here, but now we've got this level 4. So it's a much higher policy level in which we're showing the attribution of these observed changes. And exactly what this platform is showing us is you can go in as a policymaker and look at those and try to assess it. And the process understanding, which is this 3rd tier of the monitoring guidance, is the one thing that feeds into everything going up. But that's a much higher level scientific obligation. So are we using this to not only use it for the Minamata Convention? Of course, we've got the LERTAP Convention, the UNECE LERTAP Convention, in which this information can be easily fed. We will use this to improve the coordination with long-term programs within regions. So within Europe, Asia, and North America, the other, I don't know why I've missed the other regions here. It's not just ours. So that was an error, sorry. To promote the development of sustainable strategies for partnerships within developing and developed countries. So this is actually enabling our developing countries to partner on an equal level with us, and also to provide support to intergovernmental fora such as the Arctic Council that uses this monitoring data and policy information to make their decisions. So the next steps for us are to keep developing the platform, linking to other networks, and engaging other models in the process to sort of really strengthen the model part of it. That's will be fantastic. To engage with other networks, I've already mentioned AMAP. We want to engage with EMEP, the European Mercury network, and a new network that is the GOS4M, which is a newly online database for mercury stable isotopes, which tells us a lot more about the processes and attribution work that's been going on. There's so much work going on in isotope observations. So again, linking to other media such as wildlife, and engage more and more countries in GOS4M. So I just want to thank you all for listening. I apologize for the hiccups in the presentation. I want to thank my partners here. We didn't introduce Aurélien Domergue, who is here from CNRS in France, and he can answer also very good questions. And I just want to thank everybody. And I'd like to, I have now about 10 minutes or so to provide any answers that anyone may have. So I think I will stop sharing my screen and hopefully you'll be able to see the panel. Does that work now? So I see here, we have a nice question here. It says, very interesting to see how other conventions are addressed. My question on the US Climate Convention and how we can do that. I'm going to let Nicola respond to that one because he's our high level person here.
Thank you, Sandy. That's I don't see the question UN climate. This system is quite okay regarding well, that's climate change, the impact of climate change. Well, there are a lot of studies. Perhaps Aurélien can talk about this on the permafrost in the North Pole.
Yeah. Okay. Yes. Of course, this is a quite challenging question because the climate change affects radically the Mercury cycle, and on several aspects. And this is clearly difficult to see in which direction it will drive the Mercury impact and the change in Mercury exposure. But for example, we know that in the Arctic, for example, because Sandy talked about the Arctic, the permafrost is a very time bomb because it stores a lot of mercury, and with the melting of the permafrost, it will probably release lots of this legacy mercury that has been stored for centuries and more than that into the Arctic ecosystem. So which could have dramatic effects. But for sure, this is really linked, and any effort into mitigating or preventing any use of fossil fuel combustion, such as coal combustion, has some real effect on the Mercury cycle, in the sense that it will also decrease one of the most important source of mercury.
Yeah, so there's benefits certainly from other actions under other treaties. So it's not only actually the climate reduction treaty that will help us with hopefully changing temperatures, changing exposure of mercury, reductions, but also you've got other sort of the coal burning has also a better reducing of coal burning. So not treaties, but government policies and government directives, because then you get less acidic emission, and the acidic environments in aquatic ecosystems enhances methylation of mercury, and then it gets to be a big problem there. So there's a link between several different areas that has an impact on mercury.
Another point that we may highlight, because of course climate is the main driver nowadays, impacting on almost everything moving in the air. Another important, a lot has been done already by reducing emission of other pollutant like PM, for example, VOC, and also you should consider that mercury is a strange beast because it is a semi-volatile metal. So at ambient temperature, you can find this in gas phase, in different chemical form, and can be you can have a partitioning between the water and the atmosphere, can be re-emitted, redeposited, but also on the particle, on suspended particle, depending on the composition of the particle, you can have, more or less, rich in mercury, depends on the composition. So it's a lot of interact with a lot of air quality policy and environmental policies. So if you touch one policy, you can have an impact on the mercury outcome, because this will change some mechanism in the water ecosystem or in the air or at the interface or between air and the vegetation. Also mobilization of mercury in the topsoil is another issue. And so it's kind of, it's quite complex. That's why it's interesting to work with the chemistry of this contaminant together with the other contaminant, because it's not independent. So the behavior is quite a different level. So that's you have to have a clear picture of what's going on in the chemistry side and the physical side.
So one other thing I'd like to say though is with regard to the idea of the permafrost melting and the changing the impacts that climate change have on our system, the beauty of something like our understanding of the mechanisms and this mechanistic model that's demonstrated within our GOS4M platform is that you still can see the impact of the change in the emissions. Even though we understand and there's some processes we understand, some processes we still have to really fully assess in terms of the impacts, for example, climate change on the ecosystem, we can still nail down the impact of changing emissions on the different regions and the different areas. And I think that for policy is one of the key things that's important about this platform and important about understanding the whole infrastructure of Mercury. Because we still, even though we still have a lot of uncertainty in understanding the natural anthropogenic impacts and how much climate change is going to impact, how much other types of impacts are going to have on the system, we still have this function where we can see the impact of the fundamental anthropogenic emissions. Okay, I see there's
another question, perhaps something, a last message that we can give to the audience is that we need still to push forward the sharing of data, sharing of observation. One of the main goals of this flagship is really to work with the national and the international programs in order to make available all kinds of measurements related to mercury that can be used to validate models. Because afterward, the policy will use model for projection in the future. So this is one thing, and also to promote open science. Here we are to promote open science meaning open data, to make available data that everyone can use and play with. So the knowledge hub that is available on the website of GOS4M is meant to provide useful tool to all those that are interested to get an insight. So we really invite all interested, scientists, policymakers to talk with us and work with us in order to make this open science a reality, opening up databases and knowledge and make sure that all this knowledge is transferred to the end users, whoever they are, policymaker, citizen, or any kind of institution that can do a good use of knowledge to improve people's quality of life.
So there is a comment here in the chat that says it would be good to have all these insights on mercury and climate and other policies in a blog post from the GEO website. So I think that's something we can absolutely do. It's a very good way to think about the interactions between the various multilateral environmental agreements and how they do impact each other. Yes, it's a very good idea.
Good. So we have almost less than a minute left to close the session because they are quite strict. So if there is any other question, you can also contact us later on by email. You just go on the website and you have all our coordinates. Just email to us and we can have a chat and talk, have a dialogue with all interested persons, parties, and organizations.
Thank you, everyone, for listening, and thanks. Enjoy your day.
Thank you. Bye-bye.
Thank you, everybody.
Thank you.